Hello, welcome to the Code Jazz of Snake. Today we will do the official reskin for Easter of the Snake project. So let us jump into it. Reskin for Easter. What I would like is that the nuggets, so remember what we have right now is something like this, a snake, and can eat nuggets like this. So what we would like is for the nuggets to be eggs like this. See, some Easter eggs, and the snake, I was thinking maybe something like a rabbit, and we already have like orientation, so it could be seen from the top, and you would change direction like this. I'm not gonna try to draw it, but let's see. So let's start with the eggs. Eggs. So in Arcade, which is our Python library, I think there's a way to draw sprites. So sprites should we use when you code a game. It's basically an image. So how do you draw a spike? Drawing. There's drawing bitmap. That could work. Or drawing sprites. Let's see if it's a little more complicated. Queen list.draw. What is the queen? Queen list, where is it declared? Okay, it's a sprite list, and there's one sprite here. Okay, so you do arcade.sprite, the path, and sprite scaling. Okay, seems easy. So let's try to find it, and we'll just check what kind of file type it supports, but probably most of. Okay, so it's created with a file name. Sprite file name. Okay, it does not say which it supports. I'm gonna assume it supports mini. Let's try to find free images. Royalty free image sister egg. Is that a thing? If we go here, lots of free images. Okay, which one should we take? I think I'll go with this one. It's not super Eastery. I need some more keyword like cartoony or something. Yes, something like this. Which one looks great? Shutterstock, the site, it's free if you create an account. So it's too complicated. We have great free clips, alright. Yeah, what about this one? It's nice. Save image in Snake. It's egg, Easter egg.png. Let's go in the project. We have the view here, and here is where we draw the nuggets. So right now I'll show you what it looks like. The nuggets are a red circle like this. We'll try to use the new image. So the sprite will be arcade. That's sprite. The path to the image, let's make it images slash Easter egg.png. It has a X, Y, stuff like that. So does it mean that when you draw it, you don't tell it anymore where it is? If we do a draw, okay, so it contains everything about its position. File name is this. File name, what's the rest? Sprite. Where you sprite, okay. Scale of, I don't know, image width, image. So I'm looking for the scale thing. Scale the image up or down. One is original size, blah blah blah. Okay. So we have to scale it. Let's open it in Paint and see how we can change it. And yeah, by the way, it will be in images. Okay, if we resize it to be 256, 200, don't maintain the aspect ratio. It's kind of weird. It's kind of weird, but let's go with it. How do we resize the canvas like this? Okay. 256, 256. Okay, so it will already be square, so we don't need to do much with it. So let's make it scale of 1. I'm looking here, image X will be the canvas X. Like this, Y. We have a width. So let's try. Let's look. I'm not sure if it's the width of the original or the final sprite. Image. Oh, it does not see. Image width. It does not see. So I'm gonna assume it's the final. But I don't know. I don't know if it will stretch them or not. So width. You have the image height. Image 8, center X. I don't know why we need the center X. Repeat count. Oops. Okay, I'm curious. Let's try it and see what's up. Oops, I forgot to draw it. Sprite.draw. Okay, we don't need to draw the circle anymore. It crashed because attempt to draw a sprite without a texture set. Okay, what does it look like in here? And we have the acquainting. Oh, there's a dot resource. Maybe it's important to start with this. Attempt to draw a sprite without a texture. I'm gonna Google it. Attempt to draw sprite without texture. Arcade. Textures. Okay. I will get back to you because I have my Easter reunion, so we won't have any egg, but it doesn't matter. We have a cool game anyway. I ran out of time a little bit. Hello, hello. So I'm back from my family Easter reunion, and it was very nice. I could show them our little game of Snake with the new skin for the Easter bunny and the Easter eggs. So what I did is right before the reunion, at the last minute, I code a little bit of stuff, very dirty, but just to make it work. So there's a parallel there with the real world. When you work in a company, you have to sometimes cut corners on the quality to ship faster. So this is one of those instances. Uh, the the name for this is called tech debt. So when you make a little compromise on quality to be able to ship faster, you'll see a lot of companies in the startup mindset will do this a lot. We just want to ship a prototype, get funding, and then we'll make something better if we get to it. So this is an example of it. I didn't record myself doing the quick changes, but I'll show you what changed, and we'll now clean a little bit of the tech debt. So we'll repay it, make sure everything is well tested, well coded, and then we'll do the commit. So here is the code. First I will show you what it looks like. So I was able to have a little bunny like this as the head of the snake. And we now try to catch eggs. Oops, I died. So it's very prototypey, but it works. It's fun to show to my family. So that's what we have right now. Um, you'll see some corners that I cut. Can explain them while we look at it. Um, I didn't make the bunny turn. So initially I wanted to make him face whichever direction we're going. That was not done. Another thing I skipped is the tail of the bunny. It is not, it's just I kept the same circles that we had before. Um, what else? You'll see a little bit of clipping. You see how the tail and the bunny is displayed on top of the egg, and we see a little bit of the white square hiding it. So ideally we would want some transparency there to make it look better. What I did do is do the collision with, I'll show you the walls. The walls kill you, and also the collision with the tail. Let me try and build a bigger tail so we can hit it. Alright, let's hit the tail, and you see that it killed me. And there's also a little message here. It's in French. It means, oops, happy Easter. Here's your points, 9 points. So the point is just the size of the tail. So basically that's what changed. We can look at the code. So we have our two pictures here. So I found them, I think it was in the previous segment of the video. So we found this rabbit head and this bunny, and I just resized them to be perfect squares. So they're in the project here. In the view, I found how to draw the sprites. So it looks like this. Remember before the nuggets were just a red circle. So now we're doing arcade sprite with the path to the image. The scale is how the image will be stretched, and center X, center Y is where we want to draw it in the game. So we want to draw them at the canvas position plus at the width, so it's right in the middle of the cell. So I did the same thing. It's very similar. I did the same thing with the head. So you see, one tech that could be also to reuse some of this code because it's all the same except the path here. And I'm not sure if the scaling is the same. Yeah, it is because I resized them. So what changed in the main? I changed a little bit the frame period. This is to make it run faster. So what we had before was frame period 2. and I just thought it was less interesting to watch. It was almost impossible to make a mistake because it's so slow. Remember, eventually we wanted to increase the speed as we go, but for now I just did a quick change like this. What else changed? I changed the cell size in pixels, so I doubled it just to make it bigger. So everything is bigger. I wanted to make it easier to see when I share my screen. What else changed? I reduced the map size. 50 was way too big. It would take forever to hit a wall or something, so there was less chance to make a mistake. Also, what changed in the game? I did a quick and dirty way to code it. So this is for when the segment, for each segment of the tail, we check if there's a collision with the snake. And if there is, we write our def message with the score and exit the application. You see here, we also check for the snake position if it's out of bound. But you see I hard-coded the values here, -1 and 20s when we are out of the game. So we want to fix it. Also, I just noticed that we check this for every segment of the tail, but it does not make sense. It could be checked outside of the loop to be a little bit more efficient and not just the efficiency, but it's not related to the segment of the tail, so it makes no sense to leave it here. So that's it. So let's do a little bit of cleanup. Okay. What can we commit first? We can commit the view here. Yeah, so we'll add our two pictures. Add files, and the view is opened here. So you see that draw snake head and draw nugget are very similar. We'll extract it. So what we might want to do is a function. Okay, so let's see what does it depend on, the sprites? It depends of the original size of the sprite. Let's make some comments here. Okay. The original size of the original size of the sprite. So if I open Paint, you will see that, for example, the egg is size 256, 256. Same thing for the bunny, but it could be nice to support different sizes. So depending on the size, we will have a different scale. The scale depends of the original size and the size of the canvas. And we'll write the minimum because if, for example, the canvas looks like this, we want our egg to be stretched like this. So it has to scale with the smallest size, or otherwise, if we scale um, yeah, actually it scales in all directions. So if we have along something like this, it will look like this. So that's why we want to scale with the smallest direction, because if we scaled with the biggest one, it will actually look like this or something. It will be too big for the cell. so it will depend on the minimum canvas size. What is here? That's perfect. The center of the canvas that could be shared with both. Okay, so if we have a function that takes the canvas and I'm not sure if there's a way to check the initial size, but it could be a function that just takes a path and that's it. So let's try it. And also another thing that we can improve in the second step is I think here it will open the file on every time you draw the nugget. But actually we just need to load it once at the start of the program and we can remember that sprite. And so we're gonna use it a little bit like a stamp. It's like you create the stamp, you load the file, create one stamp, and then with the stamp you can make the copies everywhere you want with different scales and position, but it will always use the same source image. So load sprites only once. This is a to do extract method to draw sprites. To do load sprites. So you see if I write it like this, to do, in the IDE we have a list here so we can find all the to-dos items. So we'll just write all our ideas in the app and then we'll change them. So the game, what changed is here. Okay, we want to the snake position out of bound moves out of this loop, and to do we want the snake out of bound to not be hard coded. So it will out of bound depending on the game size, not hard coded. Also we can be a little less rough. Right now it exits the program. We probably want to print something on the screen and ask if you want to create a new game and stuff like that. So let's call it a smoother def. Do not exit. Create a new game. Something like show the score. Ask and create a new game. Excellent. In the main, we change the cell size and stuff. I think that's good. You can keep it like this. It's fun. Maybe it starts a little bit rough. So what we want is to maybe start slow, so we don't just go straight into the wall at first and then speed up. But for this, we have a task. This here. Oh, is it here? Speed up snake proportionally to its size. This one will make it like here, because it's annoying. You see that die with eating tail, walls that kill you are already done. We're just working on cleaning it up. So we have all these ideas. So I'll put it back to be slow at first, because it will be easier to test. What else do we have? Yeah, all the to-dos are here. So what will we start by doing? We'll work on the view. So draw the your extract method to draw sprites. That will depend on the original size and the canvas size. So we can have something like draw sprite. And actually, what we can do is give it the file path or something like that. Let's call it the image path. The image file path for the sprite, and we need, of course, the canvas. Let's move it first. We also have the sizes, the original size of the sprite. I think if we have the file path, we can open the file and check the size. So I'm gonna not add another parameter for it. Depends on the canvas size minimum, that's good. So it will look like this. And when we draw a nugget, we will draw the sprite images slash Easter egg.png, and give it the canvas. And here we'll have the rabbit thing. Alright, it's a lot easier to read right now. Draw the sprite areas where the fun is. So we did that, we extracted it. Now it has to depend on the original size of the sprite and the canvas size minimum. So what is the image size? Let's call it image width and image 8. Okay. I'm not sure how we will determine it, but what we can do is actually this part we can TDD. The calculation of the scaling, this is TDable. The only part that's not TDable is the like loading the image. Like we can't really have a test that checks that it's an actual rabbit or something like that. It's impossible. And the draw, it's all subjective stuff. I'll use here the image file path. Okay, so the scale, let's extract a method called get sprite scaling. Okay. So what it needs is the image width, image height, and the canvas. Right now it returns 0.2, but we'll have we'll make some tests with it. So let's start with this. Change, yeah, we have to add the values here. Canvas with 8. Okay. So we know that this is possible. The only thing that's risky is the image width, image 8, so we'll just make sure it's possible. In arcade, if we have an image, is there a function for it? Resource, maybe? Resource files are images and sounds built into Arcade that can be used to quickly build and test simple code without having to worry about copying file into the project. Okay, so there are some things that are like built in, if I understand correctly, but that's not what we want. We want, unless there's like a rabbit, that we want to use external files. Oh, that's pretty cool. Some coins, flags and ladders, and ships. Is there a rabbit? There's no rabbit. No egg. Okay, so we're not using resources. Arcade, get image. What is this? Get an image from the screen. Okay, you can take like a screenshot of the screen. That is not what we want. Trim image. It's not what we want. Maybe it's something about the sprite. Is there like a size? Sprite. Arcade, that sprite. Where is it? I can't find it anymore. Arcade, that sprite. Okay, what does it have? And then go already on button. Boundary. Okay. Center change. Height. Left. Right. Set the query the sprite location by using the right coordinate. Um, yeah, maybe it will be set. Let's try to debug here and try it. So actually, I want to debug here. So we have a sprite. Is there something of value 256? Doesn't look like it. Sprite dot height is 51. Okay, this is because it is scaled. So I think we can first create it without any scale. Let's try this and see if it works. Sprite that height. Yes. Okay, so that's the original size. So we first need to create the sprite like this. Without any scaling. Get the image, width and stuff. And set the scale right here to sprite dot scale is equal to this. What is this used for? It's used here like this. Okay, so I think right now I didn't change any of the behavior. So here the image width is the sprite dot width. Or you know what? If we just give it the sprite, it makes more sense. To just have a sprite here. And it's the scaling part thing that will take care of getting the width and everything. Okay, so if we run it, oh, it is broken. What happened here is that must be real number, not tuple. Okay, I messed something up, but I don't know where the error is. Okay, it's here. If I run one step, there's no error. Ah, yes, we have an error here. Can we see it? If I do E, it just says must be real number, not tuple. Um, okay, so the error is when we draw, if I understand correctly. Yeah, this is, you see that it didn't continue. It stopped here and went back here. So when we draw the nugget, there's an error. And that's when we draw the sprite. And the error says must be real number, not tuple. Okay, I think we have to debug, so I'm not sure. So here the f width, f8 are good. And yeah, let's just inline them. It's not very useful. Like this. Canvas.x, that's an int, that's a float. Okay, the file name, I think is okay. The get sprite scaling returns a 0.2. There was a comma here. I think that just did. Yes. Okay. So it's time to do our test for the sprite scaling. So it will be in test view here, test sprite scaling fit something like when getting sprite scale, then when scaling sprite, then it fits in canvas. Okay, so what we have is a canvas and a get, what is it, view that scale, I forgot the name, get sprite, why is it not working? I have to import it. So we have a canvas here and a sprite. Okay, the sprite, the only thing that matters is that it has a size. So what is of interest is the original size and the size at the end. So we don't care about loading a real file and everything, just that. So let's create a sprite. We can use the can we do this like this? Object sprite.width equal to 10, sprite.height is equal to 20. Just gonna make sure it's possible to do it. Assert that sprite.width is equal to 10. We're gonna run the test. And object has no attribute width. Okay, so it's not possible to do that. Let's see, we have what was it when we did the stubs the other time? Allow, doubles, allow. Doubles, doc, Python. I think that's it. Where is the doc? It's here. How do we... I think that would be it. Stubs and allowances. Actually, I think we can create a class this or Anna Python anonymous class. That's something that exists. Like if you want to create just an object. It's a dict. Okay, I like this idea. Let's go back here in the test. It's a dict, and it will have a width 10 and a 8 of 20. Okay, so we have an homemade stub for the sprite. The other fields, we don't care about them for now. Is this the correct name? I deleted it, so I don't remember. But I think so. So, what's the problem here? With what's the problem for this? Okay, apparently I don't remember how a dict works. Python dict get element. Dict that get key. Okay, the keys are strings. But that's not what we want. Dict key. Is it possible to have like clearly it's possible to have a symbol like this, but how do we use it? That I'm not sure. Python dict non-string key. Do we have something interesting here? Hmm. Okay, we can have numbers. Restrictions on this dictionary keys and values. Almost any type of value can be used. Dict key symbol, I think that's what it's called. It has no symbols. You could do an object, then set a dictionary key as some var. How do we stub it? We need to be able to get it. I guess we need to do some kind of class like this. Sprite stub. Self.width is equal to 10. Self.height is equal to 20. and then we'll create it here. Okay, so we have that's what I would like to have, like an easy tool in the package here, but I'm not sure it's possible. Okay, let's make it work first, and then we'll check if it's possible with this library. So we create the sprite from the stub, and it should give us this. Why is there still an error? Sprite stub object has no attribute width. Oh yeah, we need to make it a constructor. Yes, it's working now. Okay, so for the scaling, let's make a drawing. As always, this is the canvas. Let's say the sizes are 10 and 20. So it should use the smallest size. And let's say the source image is like this. And this one, it's like 4 by 2. So the biggest size of the sprite has to scale up to the smallest size of the canvas. So this one divided by this one gives us the scaling factor, and that's what we want to return. In this case, the scaling would be 4 times 2.5, give 4 times 2.5. That's the scaling factor that we expect. It will give us 10. Okay, so at the end it will scale to be like this. So as you can see, the biggest size here will scale to fit with the biggest one. And actually, if it was like this, we would scale. Yeah, we need to calculate both scaling factors in both directions and return the smallest one, I think. Because if this one needs a scaling factor of like 20 and this needs a scaling factor of 2, if we pick, like, it's not right, it's not true what I said about scaling the biggest one with the smallest of the canvas, because this one, it will scale like this, so it might be too big for it. Yeah, so we need to find the smallest scaling factor of the two. So we will have like a anyway, I'm thinking ahead. We're trying to write the test. So the first test will be this 20 and 10, and something that looks like this. So it will be 5 and 1 or something. So we know that it has to scale, it will look like this at the end. The scaling factor should be 2 because it will be 10 by 2 at the end. Okay, so this case is when I feel like there's 2 cases. It's like when you're scaling with the same, like this is like scaling in X to fit the X canvas, but sometimes we will okay, well, let's make it like this. The scaling in X will fit. So it's a 10 by 20 canvas. Let's just put it at 0, we don't care. 10 by 20 canvas. And the square is a 5 by 1. 5 by 1 sprite. It should get sprite scaling. The sprite scaling should be equal to what is it? 2. Yeah, it's a scaling factor of 2 because 5 times 2 gives us the maximum width, and 1 times 2 doesn't give us it. So yeah, it's a scaling of 2. Of course, it will fail because we didn't write the code for it. We hard-coded .2. So we see here .2 is not equal to 2. Let's make it. So what we want to return is we have like a potential scaling in X, which will be the canvas dot canvas width divided by the sprite width. So if we do this, it will pass, obviously. But obviously, I mean, obviously it's broken, but it passes our test. So what we're doing is when scaling what is it? Scaling sprite, scaling to canvas horizontally is this. And we have another case where we want to scale vertically. So let's say we have the same thing, 10 and 20, but we add something like this. Something like this, and it's 8 of 4, so we expect the scaling factor to be 2.5, no, I mean 5, because 5 times 4 will give us 20. So we need something like 1, so that 1 times 5 is smaller than this. So it will scale like this, something like that. Yeah. So 10, 20, 1, 4. 10, 20, 1, 4. The sprite scaling should be 2. I think we will see an error. Exactly, because we are scaling the horizontally. So 1 times 10 will give us 10. What we actually need is to check for the potential scaling in Y. Or we can call it horizontal, vertical. Okay. Now the question is, how do we decide between the two? So if we scale horizontally and yeah, both scale gives us like exactly the canvas size. So if we take the biggest one, maybe in the other direction it will scale too much. So we need to take the smallest of the two. It's the minimum between horizontal and vertical. Okay, it did not work. What failed is we have 2 is not equal to 5. And yes, we were expecting 5. I forgot to change the test. So now it passes. So I think we're good. Is there any other edge case? What did we redraw here? No, we said just to make sure it's not always the biggest one with the biggest one. It can be mixed up. Yeah. So we know that this works. We can use it now in the view. And before we do this, let's try to see the bug. So if we resize, oh, we can't resize the view actually. But what we can do is resize it here. If we say that the pixel size is like 5, now the rabbit and the egg should be like way too big. Oh no, actually, we changed it already, so it's already good. So before we were returning 0.2, and see how it's super big. So yeah. It's now working. All the tests are passing. Excellent. So we did this extract method to draw sprites. Depends on the original size and the canvas. This is completely done. And now the load sprites only once. What we can do for this we can have like a view, something like load. This will load the view. So all the sprites. Load images. Here is the image that we want. So the rabbit sprite rabbit is arcade.sprite this. So initially they will be none. This is the egg, Easter egg. Okay, it's like this. What's the problem here? Shadow's name. It's not working. I think what we will do is create a class. So we'll have a view. It will have a self dot sprites like this. Some images. What's the problem? It may be static. Sure, make it static. No, it's not static because we are loading it like this. Self dot. There's no self. Okay, we're getting somewhere. So when we create a view, it starts with none, and when we load the images, it will load them like this. So it is not static. It loads the images just once, and then get add vertices. The add vertices, let's make it like so. So this one is static. At stat, how do you do this? Static method. Excellent. Draw, get sprite scaling. Everything should be inside. A lot of them are static. If we draw the head, this is not static because we need the sprites for this. What's the problem? Too many blank lines. Alright, so we're going object oriented on it. Self. Unexpected argument. You're right. Because it's the self.sprite rabbit. This. So we have directly a sprite. A lot of boring stuff, but we're getting there. self that gets sprite scaling. Okay, this is actually static. Because it depends on the canvas and the sprite. Load sprite only once, we can remove this, we're doing it. This is static. Draw circle is also static. Okay. Does it work? If I run the test, I expect some errors. Top level, collect, oh, here, from the view, import view. Let's wait for it to ask us. So what we're doing here is creating a view. And the view it's the view that is doing this. I get add vertices. Excellent. So we need this everywhere. Because we need it everywhere, we're gonna make a setup. So it will only be done once. I'm not sure of the spelling. Let's try it. Self.view equals view. So every error are caused by this. We have a self.view, 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 self.view everywhere. Okay, it's passing. Excellent. So now every test creates a view like this. The canvas, it's okay if they are different. It's not all the same thing. Does it actually work in the game? It does not. Because here we need to have the view. Now self.view. Let's make a view. When we do the setup, we will load the images of the view here. So view.load images. There are some errors here. Self.view. Does it work? Division by 0. Okay, that's not good. Is there a way in Python to print the stack trace? That would be useful because we don't know exactly where the bug is. Except that unable to load sprite object. It has no attribute read. So the load is probably here. Maybe the name is not good. How do we create a sprite? Yeah, the first thing is the file name. So I don't know what the problem is. Okay, let's find out how to print the stack trace. It will help us. Stack trace is when you see there's an error and it says this part of code was called by this function, this method, this function, this function, this function. So we can trace back how it happened. Okay, something like this maybe. Print exception information and up to limit stack trace entry. What is print TB? That's the traceback. So here we have an exception. I think that's what we want. Traceback. In the main, when we draw stuff, we want here to import traceback, print exception E. Let's try it. We'll see. Okay. Okay, so we're not using it well because it needs some parameter here. If E-type is syntax error, okay, so what's the E-type? There, like something like type E-type. Okay, let's see some example. Print exception. There's also this exception type. Maybe that's what we want. Print exception. Here we can format print last, print track. Okay. Looks like we want this, and these are optional. But if it has no parameter, how does it work? Okay, that's what we want. Print exception. So we have a zero division error. This is the stack trace. And we have our message, error while drawing division by zero. This is repeating itself. We could remove this. Or I would like to have this message. I think we can specify it somewhere. Probably here. If we do a print exception, there are a way to have a cool string. Format exception. Okay, there's no way to do it, looks like. Let's just get rid of it. Too broad. Yeah, it's too broad. I agree, but we don't know what to expect. So we have to keep it like this. So you see how it will be useful to debug. Now we have a zero division error. Division by zero. It happened here. So the sprite width was of size 0. This is when we called it here, draw sprite. Called by this. Okay, so in the main, we were drawing a nugget. The nugget was drawing the sprite. And I see here orientation is not used. Let's make a to-do to remove it and come back to it later. Orientation. Okay, in the main, we're drawing a nugget, drawing a sprite. When we're drawing a sprite, we are creating a sprite. Get sprite scaling. Yeah, I think it's just I added the line, so it's not aligned correctly. So we're here getting the sprite scaling, and here is the division by zero. Why is that? It's because we're trying to draw before it's initialized, maybe? Before it's loaded. Is that true? Why is it not loading the images? let's see here. When we draw a nugget, do we have valid stuff? Self dot sprite. The nugget is the egg here. It looks okay. We have the width of 256. If we get in, oh, file name is equal to sprite. That's not good. We need to change this. We're actually just changing the sprite.center center x and center y is this. So we don't need this actually, because we already have a sprite. So let's consider the sprite like a stamp, so we can move it, we can scale it, and then do a stamp. Does it work? Ooh, there's some creepy, weird bunny stuff going on. What could cause this? Why is the bunny so big? Is there an error here? It didn't print any error, so it's not like a division by 0 or anything. Okay, is it just the bunny that's weird? Let's make it bigger here. What? Okay, sometimes it looks like it goes back to the original size sometimes. That's really weird. The rabbit. When we draw the snake head, like if we remove it, of course there's no bug, but it does not do anything. Okay, so it's really here. When we draw the snake head, we have a canvas and a sprite. We change the sprite position and we scale it. What the hell? Sprite, change its position, scale it. Okay, what's the scaling? the sprite dot scale 0.11. If we do it a couple times, oh, here it's 1. Okay, so why is it 1 in this case? We have, let's look at the canvas. No, it's a width of 30 and an 8 of 30 also. So something weird happened. Something very weird happened and it gives us a scale of 1. What could do this? It's when I think the sprite is already, when we do this we change the actual initial sprite, so I think we should make a copy every time we draw it. So yes, when we give it a sprite it should not change it at all. So here we have like a source sprite and a sprite here which is a deep copy of the source sprite. So the source sprite will always be at position 0 and a scale of 1. Yes, it's working. Perfect. So that's it. The problem was that we were modifying the source sprite and we don't want to do that. We want to keep it as like high definition as possible, as big as possible, and every time we use it we will make a copy, change its position, scale, and it will not affect anything else. So I think that's good. Let's see in PyTest. All the tests are passing. That's wonderful. So what is remaining in the to-dos? View, we can remove the orientation. I think it's gonna break a lot of stuff. So we'll use the tool here, refactor. Oh, maybe it's here to change the parameters. It looks change signature, that's what we want. We want to remove the orientation. Or actually, no. It's the other way around. The to-do should be to make it rotate. So when we draw the snake head, there's probably something to rotate. Sprite. Okay, this is the sprite, and there's an angle. Angle. So we want to draw the sprite. We'll have an angle or let's say our orientation by default angle by default it will be 0, so it won't turn. And or not even better, we have an orientation by default it's down. No, angle 0 is good. Angle 0, we will do a sprite that angle is equal to angle. And how do we decide the angle? We'll do a test for it, but it's gonna be here. Orientation self dot orientation to angle. Let's make it static. Perfect. So we will create a test for it. Is there a way to easily create a test? Does not exist. So let's get in the view test orientation to angle. So if the orientation is down, the angle should be 0. So assert that 0 is the self that view that orientation to angle down is 0. Let's make all of them 90 degree, 180, 270. This is when we're looking right, looking up, looking left. Does that make sense? And if you run the test, it's failing when it's looking right, because here we need to make it so that if orientation is down, return 0. Actually, even better, this is like a dict, so the conversion is a dict like this, and we have down is 0, and what we'll do is return the conversion element at orientation. "90, 180, 270, down, right, up, left." I'm just guessing those are the angles. Typically, what I saw in other frameworks before is that this is the 0 and it turns like this. So we have 90 degree, 180, 270. What is the problem here? Bad indentation. Does it pass? It passes. Does it work in the app? Yes, we have our little bunny. That's nice. Hmm, pretty good, pretty good. What is to do? Stuff like this. Okay, I think we can do some commit here. So we have the game. Let's just fix the error here. Reformat. Okay. No, we have to do this. Out of bound, moved out of this loop. No, I think we can do it. If we don't commit this file, we don't have any collision. It makes sense, it's like another commit. We have our two pictures. The main, what changed in the main is a bunch of stuff like this. Just the size. I think we can even make it bigger. So that we don't see the bunny in its full potential. Let's make it like twice as big. The cell size in pixel should be 60. That's pretty big. It's like too big for my screen. So we'll make it like 40, 50. Sounds good. So we change the size, create a view object, it loads images, have some better error handling. So we can keep this error while handling the game. Import this. If we do this, we have a division by 0, error while drawing the game, and we should have a line skip. I think I prefer this way with a print and the file something like this, I think. No? Yes. So we have the new line for free. Error while running the game. And we have the trace back. So it makes sense. You scroll to see your error, and the first thing you see is a high level description, and then you can dig down. So I like it. We can print the error, print the trace back. Here we just refactor to use the view. The orientation is the same. The view, test view, we create a test setup, use the objecting, test sprite scaling to canvas horizontally, vertically. Maybe we can improve the sprite stub. We'll have a look in the doubles library. And we have a test orientation. So the only thing we don't want to commit is the game. The view is also correct. And there's no to do in the view. So it looks good. The draw sprite, draw NuGet, draw snake are both using draw sprites. Does a job. And you can get the sprint scaling. And that's it. And even like the tail of the snake could be better looking. Maybe the tail could also be eggs. What do you think? So Easter egg. Now we have some nice eggs here. Okay. They could be two different colors just to make them easier to see. And I like this one because it's round, so it will not look weird. And maybe this could be what follows us, or one of these. Since they are all the same size, we could pick like a random sprite among these. It would be cool. This one is also the same style. Oh my god, look at this. The bunny could have a bunch of baskets with eggs behind it. It would be fun. Um, broken eggs. This is fun. I think it would be weird like you pick one egg and you have a bunch of baskets. But look at that, gold eggs. Maybe the bunny could transform them into golden eggs and put a little ribbon and it follows it. I'll open it in case we don't find something better. Look at that. That's a really nice website. There's a lot of cool ideas. I like it. Okay, so what have we got? We've got... oh, it all opened the same page. I want this one, this one, this one, this one, and this one. Can you spot anyone else? No. Free Easter stuff. There was like this golden egg with a ribbon. Not, it was not this one. Um, oh my god. What about you pick the eggs and it hatches a little chicken and the chick follows you everywhere? That would be fun. Do we have chicks? Chick. We need a chick that looks in front of us. Hmm. I like some of them, but they don't have the same style as the one that is the eggs, so it would look weird. Like this one is like too polished compared to the eggs. We need like a chick with like a single color. This one, maybe. We are not lucky. Not lucky at all. Because these ones will be weird because they would like walk sideways because we're looking at them from the top. This maybe, but they would be hard to see in the background, so we would need to change the background. It could be like a grass, the background. I think I like it because it looks towards us. This one is kind of ugly. Don't tell the author. This one is bees. This one is not bad. There was a Winnie the Pooh. I like this one a lot, but it's not centered. Let's try this one, see what it looks like, because it's the the most beautiful chick. Or this one maybe. Yeah, this is totally the most important part of the project. Yeah, I like that they are walking because it would not make sense to have like eggs following you design wise. Okay, so we have a bunch of eggs. Okay, save image. Blue egg, green egg. This one will kill it. We'll have a yellow egg. It's so nice that they are all of the same style. Purple egg. Um, This one is a pink egg. Okay, now we have to decide of the chick. This one is really cute, but it can't walk. It's still in the egg. Does not make sense. This one is awesome. What the hell? Not this one. A little rabbit like this. There might be a better rabbit. If we find a rabbit that looks like this style, it would be really cool. Okay, let's kill this one. The baskets. We were thinking maybe basket, but it does not really make sense. Easter bunny. This one looks pretty cool, but I don't think we want that. But maybe. It's either a chick or golden eggs. And the bunny, can we find a better bunny? As much as possible, if we can see it from the top, it would be better, I believe. Bugs Bunny. Maybe our bunny was the best one. Yeah, I can't even find the bunny that we had. Maybe we wrote like rabbit. If he has like a basket in its hand, it would be the best. Hmm, hmm. Like this one, maybe? I hope you enjoy looking at bunnies with me. This one with a container. So many bunnies. It really puts you in the Easter mood. Look at those. Okay, I don't know where I saw the bunny that we have, but I think it's the best one. Or it's like just a rabbit. Nah, it's not the kind of rabbit we want. Maybe a rabbit with a basket. This one, but it's not obvious which direction is looking. Look at this one. The problem maybe is that it's not really a square. What have you got for me? Internet. Nope, I think we're out of luck. So we'll keep our little bunny. What does it look like? Oh god, it's so ugly. I forgot how ugly he is. We need to change. We need to change it. Oh, there he is. Maybe this one. It's not white though. This one maybe. Let's make it perfect. Man, this one is cute. Oh, this one is not as cute. This one is very cute. I'm considering this one. Look at his eyes, and he is facing us. That's really nice. Or this one. Oh, look at him. He's so cute. Oh, what happened here? I don't know what this is. Okay, so we have, if it was a chick like this and a rabbit like this, I think the style fits together very well. And they could even pick up eggs like this instead of the colored ones. Because the colored ones, if we look at them, the style would kind of clash. But this one, you see how it's like, it has lightning and everything, like these ones. Yeah, let's do that. These three are the winners. Let's get rid of the eggs. Oops, I can't. So we have an egg. Easter egg. We don't need you anymore. And the rabbit. You are now a very cute rabbit. Images. Let's call it a bunny. It's even cuter. We have a bunny. We have a chick. Look at that. So beautiful. So we don't need you anymore. Delete. View usage. Oops. is used here. So we need the bunny dot JPEG. Okay, Easter egg, rabbit, you are dead. And the chick is for the tail. We need to make it here in the view. So we'll have a sprite chick. The chick is the chick.png. We have the Easter egg.png and the bunny.jpg. And draw tail. Where is the draw tail? Draw circle, we don't need it anymore. Draw tail segment. The segment will be draw sprite with the canvas and the which one was it? Self.chick. Oh my god, I'm so excited. Are you ready for this? Let's move it with the other ones here. Are you guys ready? Yay, a little bunny. I like it. Maybe the orientation of the bunny is weird. So maybe we don't want it anymore. Don't know what you think. It's fun because we can see the orientation. Or you know what? Maybe it should be the other way around. Like when it's going down, when it's going up, it should be as you see it when it's going down. Or just always facing down. Yeah. Yeah, I think we don't want an orientation. So all of this, it's sad, but we don't need it anymore. Oh, all the head vertices, we don't need it. That's nice. Draw the snake head. Maybe we don't want an orientation anymore. So let's refactor, no orientation. Don't need an angle. We don't even need this. Look at how it's all simplified. Yeah, it's playable. It's not like you don't know which direction it's going, you just clicked it and it's moving. Look at that, what a beautiful game. So we can simplify the test because we just got rid of a bunch of stuff. All this is useless. This is set up. Oh, need a space. What's the head vertices? It's all useless now. Look at that, we can get rid of so much. This feels good. Because it's all just sprites now, so it's very simple. Look at that, 40 line of code, and we have everything we need. This works. Does our test still pass? All the tests are passing. Test the snake. It still has an orientation, it's just the view that changed. So what changed? We need to add this. So we have all our sprites. In the game, we will not commit this. Check negative collision. Why does it look like there's an error? I don't know. So if we did not have this, I think it would still work. We have the main where we can draw a bunch of stuff. Test view, we got rid of so much. It feels good. And the view. Super simple. We know it's okay. So let's add everything except the game. Oh, I can't like remove it. Oh, get I don't know. So we'll do it by this way. If you can see, we will get reset add the game.py and commit the rest. So it's like really the only thing that changed is that we reskin the view for Easter. Reskin for Easter. And now in the game, we will. How long have we been running? Alright, we'll stop here. This was the reskin for Easter. And in the next video, we'll do a little bit of cleanup for this and mark them as done. So let's push this. Just have a look before. If we stash it, does it actually work? Main. Yes, it's working. Just that we don't have any collisions. You see, you can get out it yourself. So, did you see this bug? We'll just take a note of it. If I go really fast, left down, left up, see how it can sometimes go straight through itself. So we should prevent this. So So we'll create a bug for it here. When quickly turning and going back. Snake goes, should not go through itself. So it's like a bug. We'll prioritize it somewhere after the when you die stuff. Just like this. So we reskin Forester. I pushed it. So thank you very much. Make sure to subscribe and you'll be very up to date for every video that I make. So let's see you next time.